Algebra 1, Section 10.2, quadratic functions. The notes say here that the graph of y equals ax squared plus bx plus c has the line x equals negative b over 2a as its axis of symmetry. Now I want to highlight that x equals negative b over 2a. That's an important calculation to know, something we of course make students memorize when they're in class. And the calculation is important. The fact that it's an equation of a vertical line is also important. Notice the x equals. This is something that I emphasize throughout the year. This is something that will be a huge emphasis in Algebra 2, that when you're being asked for a vertical line, that it is in equation form. X equals a number. And be sure that negative b over 2a is a number, okay? Furthermore, it says the x coordinate of the vertex is negative b over 2a. So if you stop and think about that, I'll just draw a simple example over here. If you have some parabola like this, and its axis of symmetry is right here, and let's just say that that's the line x equals 3, okay, then no doubt that this vertex right here is going to be 3 comma something, okay? Now, how some textbooks and some teachers will present this, I want to show you that right now because I think it's kind of good for understanding as far as function notation. What we're saying is, again, if the vertical line that is the axis of symmetry, which we defined in the previous section, is in this case x equals 3, then the vertex is 3 comma something. The way you could really present that, this same idea, the x coordinate of the vertex is negative b over 2a, would be like saying it like this. The vertex is negative b over 2a, comma, f of negative b over 2a. Okay, and in my experience, students don't exactly like that. Some students don't exactly like that notation, and that's exactly why I'm showing it to you, because I don't want this to be foreign to you if your Algebra 2 teacher presents it this way. This is a number, okay? That's the x value of the vertex, and this is a number too, also, and it's a number also. You take this number and you plug it in for x, you plug it in for the independent variable, you're going to get an output that is also a number. This is the vertex, number comma number. You know, something like 3 negative 1, which is pretty close to what this one was. I was trying to make it anyway. Okay, so an example. Sorry, I got ahead of myself there. Here's an example. Graph the function y equals 2x squared plus 4x minus 3. Y equals 2x squared plus 4x minus 3. Now, the first thing you could do, of course, and the first way that I taught something like this to you just a lesson ago was to make a t-chart. And I'm not telling you don't make a t-chart. In fact, I'm going to. But this is going to help us. This calculation, negative b over 2a, is going to help direct what numbers we should choose, okay? So it's not going to be as easy as, negative 2, negative 1, 0, 1, and 2. Sometimes it is, but it's not always that. Okay, so let's do this calculation. Negative b over 2a in this case would be negative 4 over 2 times 2, okay? And let me just remind you, the 2 is the a, the 4 is the b, and negative 3 is the c. A, b, and c. This calculation, negative b over 2a, comes from those coefficients, those constants. Now, another kind of a side note, another thing to just say be careful of, another thing to remind you about, whatever this is if you're going to type that into your calculator, which I don't think anybody should have to type it into their calculator. Isn't 2 times 2 4? Isn't 4 divided by 4 1? Isn't this going to be negative 1? The vertex is going to be negative 1 comma something, okay? But if you are, or maybe this is more complicated and you need to type something into your calculator, be careful not to just go negative 4 divided by 2 times 2. You see what the problem with that's going to be? Negative 4 divided by 2 times 2 typed into your calculator like that is going to take negative 4 and divide it by 2 and give you negative 2, and then it's going to take that number and multiply it by 2, which will be negative 4. We don't want that. There you go, there's negative 4. We don't want that. You want that 2 times 2 to be in the denominator. So if you were to type this into your calculator, you better put that 2 times 2 in parentheses. Better yet, check your mental math skills and don't worry about this. Anyway, it should be negative 1. Should be negative 1. Now, why did I do that? Well, because we can make a t-chart And I would put that number kind of in the middle, so to speak. Okay. And real quick now, and you can do this with your calculator, you can do this with mental math, just make sure you get the answer right. I'm going to do mental math here. You can plug -1 in for x. -1 squared would be 1, times 2 is 2, plus 4 times -1 would be like saying plus -4 or -4. So 2 minus 4 is -2, minus 3 would be -5. The vertex is at -1, -5. Okay, now key point. What you should do next is pick -2 and -3, 0 and 1 for your other x values. Pick x values that are near your vertex, okay? Now this one came out to -1, which is pretty close to 0. Let's just suppose this came out to 12, okay? If it came out to 12 and you started at -2, -1, 0, 1, 2, you're going to have to go 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 just to get to the vertex, and then maybe 13, 14 to get a couple of good points. This is why I'm saying pick or do the calculation, -b over 2a, find out what your vertex is. That's going to be at -1, -5, and then pick values that are near it. All right, I'm going to do the math real quick here. Plug in a 0. That's going to be 0 here, and then -3 would be -3. Plug in a 1. 1 squared is 1, times 2 is 2, plus 4 times 1 would be 6, -3 would be 3. And just to confirm, if I do -2, I should get the same thing as I get when I plugged in 0. -2 squared is +4, times 2 is 8, plus 4 times -2 would be -8, -3 would be -3. Did you catch what I don't know if I said all that right. -2 squared would be 4, times 2 is 8, -8 is 0, -3 is -3. Do the same thing with -3. 9, 18, -12 would be 6, -3 would be 3. And there's 5 good points that you can plot. That's probably good enough. If you wanted a few more, the numbers that I would pick would be 2 and -4, although I don't know that we necessarily need to do that. Let's see what that looks like on a graph. I'll try to remember these now as I roll to the next thing. So there's the vertex. I forgot it. Of course I forgot it. And then these would be the 5 points that we just came up with. And draw yourself a parabola that is a curve. Again, we're not looking for perfection here, but we are looking for something that has curve to it, not a dot to dot. It is not something that looks like an absolute value function. It does have curve to it. Okay, so that's graphing that like that. Make sure that you download some graph paper for this assignment as well. My notes here say that there are a total of 8 graphs. So again, you're probably going to need 2 sheets of the one-sided graph paper for this assignment. Was there a second question here? Find 2 other points. Use the y-intercept. Okay, well, I guess the point being, I'll circle it. This point right here is 0, -3. Okay, and then another point would be just what you get when you reflect over the axis of symmetry they're using, which is -2, -3. And then they also use 1, 3, I guess. Okay, anyway. The biggest point is to be able to graph it. Does that look like what I graphed? I hope so. Okay, next one. Oh, actually, we'll go back to notes here. A little bit to do with gravity and projectiles. I mentioned this in the previous lesson. H equals -16t squared plus c is what we dealt with in 10.1. Now we're just going to complicate things a little bit with this middle linear term. The v stands for initial upward velocity. So the monkey problem the other day, or the previous lesson, where the monkey dropped an orange, simply dropped, right? It's kind of started at time 0 and fell. Whereas these would be something that's thrown or maybe shot up into the air, like fireworks is what the example we're going to be using here. This is not tracking the motion. Okay, just to be clear, this is not a firework is shot from the top of a building and this is what it looks like. It arcs up and down. Those are parabolas too. If you throw something up in the air, like think about shooting a basketball at a hoop, that's a parabola also, but that's not what we're talking about here. We're simply talking about you standing, maybe you are at the top of a building or a hill or whatever, and you're simply throwing something up in the air, and then it turns around and comes back down to the ground. Okay, that's what this is tracking. Height as time goes on. Negative 16 t squared, that's gravity. Vt, that's has to do with velocity upward. V is your initial velocity, and then c is where you threw it from. So again, here's an example. Aerial fireworks carry, quote, stars, which are made of a sparkler-like material upward, ignite them, and project into the air in fireworks displays. Suppose a particular star is projected from an aerial firework at a starting height of 610 feet with an initial upward velocity of 88 feet per second. Important numbers, remember those. How long will it take for the star to reach its maximum height, and how far above the ground will it be? Okay, so the equation that I just gave you, which is in standard form, h is the y value, t is the x value, negative 16 is the multiplier here, the lead coefficient. This is gravity. 88, t would be this number because initial velocity was 88, and the height is 610. Now you might just stop and think about what's going on here. Why is it being shot from 610 feet? Well, maybe they're shooting it off of a building or a bridge or something, right? So the fireworks aren't necessarily shooting from the ground. They're up 610 feet from, our vantage point. So that's the initial height of 610. They're being shot upward at 88 feet per second. Eventually gravity takes over and they fall back down. This is the idea. And this is further saying that at the vertex of the parabola is when the firework goes off, so to speak. Okay? Now, take a minute to understand the question. How long will it take for the star to reach its maximum height? What's the t value, in other words, at its maximum height? Well, the maximum height is a vertex, right? This is a parabola that opens down. I just drew for you a second ago the up-down thing. Well, as time goes on, the height, this is going to do that, right? So it's going to go up and then down. This is a parabola that opens down. We know that also because this number is negative 16 t squared. In which case, then we can do this. T equals negative b over 2a. That'd be negative 88 over 2 times negative 16. And I do need my calculator for that. Negative divided by negative is going to cancel itself out. So really all I'm doing is dividing 88 by 32. It's 2.75. 2.75. Now that should make perfect sense. 2.75 seconds, a little less than 3 seconds for it to reach the vertex there. That's a reasonable number. Okay. Then it says, how far above the ground will it be? Now I've already done this kind of thing a few times, so I'm just going to roll to the answer. But what you would do is take this number and plug it in for t. We're finding the vertex, which is 2.75 comma something. The something is the height. And if you plug 2.75 in for t and do the math, use your calculator, you should get 731 feet. 731 feet. Okay. One more example. Graph the quadratic inequality. So if we understand how to graph a quadratic equation, we should also be able to graph an inequality. I did use some snipping tool to bring this over to my starboard. So there we go. That's the same inequality. And I'm just going to demonstrate for you how we graph this. So basically, we're putting two concepts together. We're putting the concept of something we learned back in chapter 7 of graphing inequalities that were linear. And now we're going to graph a quadratic that's an inequality. So if we can do what we did in example 1 here today, and we could do back what we did in chapter 7 with graphing inequalities, this is going to be the combination of those two things. First of all, our newfound calculation, negative b over 2a would be negative 6 over 2 times negative 1. You see that? B is 6, a is negative 1, and that would be 3. Okay, so then I'll make a t-chart, and I'll put a 3 in the middle. And then I'll pick 4 and 5, 2 and 1. There's my starting 5 numbers. These are what I want to plug in. And for right now, I'm just going to treat this like an equals. I'm going to put in these values for x. The output will be y. That's what will go here. and then we'll deal with the inequality portion and all the graphing. So I plug in a 3. 3 squared is 9. This is negative 9. Plus 18 would be 9. Minus 5 would be 4. Use your calculator if you need to. I'm going to do this kind of fast, but I am going to use mental math. Negative 4 plus 12 is 8. Minus 5 would be 3. 4 should also give me 3. Negative 16 plus 24 is 8. Minus 5 is 3. Yep. 1 squared, so negative 1 plus 6 is 5, so that should be 0. 5 should also give me 0. This is negative 25 plus 30 minus 5. Yes, 0. Okay. And with that in mind, you know what? Well, let me plot them real quick, but I'm gonna go ahead and pick more points too. Here's 1, 0. Here's 2, 3. Here's 3, 4. 4, 3. 5, 0. I think I'll pick one more number. Let's plug in a 6 as well, which would be the same thing as plugging in 0. You plug in a 0, you're going to get a negative 5 here. You plug in 6, let's just double check. Negative 36 plus 36 minus 5 would be negative 5. So there's also 0, negative 5, and 6, negative 5. Okay, now your next thing to do would be to draw in the curve, but let's remember back to chapter 7. Since this is greater than and not greater than or equal to, we should do a dashed curve, just like we did in chapter 7. That still applies. The dash basically says don't include the curve as part of the solution set. So there's your dashed line. And then finally what you want to do is shade one way or the other. And I'll use the arrows just as I taught you to do back in chapter 7. If you want to color this whole thing in, you can do that. But basically what you want to do now is take the origin, or any other point that's not on the graph technically, but the origin works very nice. Take the number, the order pair 0, 0, plug 0 in for x and 0 in for y, and see if the inequality is true. This is very simple when you use 0, 0, because then you're going to be left with 0 is greater than negative 5. You see? I plug 0 in for here and here. This whole thing becomes 0. Minus 5 would be negative 5. Is 0 greater than negative 5? Yes, it is. Therefore, the origin, which is here, is part of the solution set. So all of our solution set is everything out here and nothing that's inside. So the way I show that for you is like this. You're welcome to just use a couple of arrows. You might want to even use a couple more to really emphasize that. If you are into coloring and you want to shade something in, by all means, you go ahead and start coloring all this stuff in right here. But the point is that nothing inside the parabola is a solution set, but everything outside is, right? So I could do this until I cover every blank spot, but that would get boring for you. So this should be good enough. Thanks for tuning in.